is equal to the conditional probability A occurs given that B occurs as well. Okay, even though actually this one is a simplified form, right? Because from here we see that this conditional probability is just equal to PA. So these two terms are equivalent. Okay. Next, with conditional probability, we can obtain Bayes' formula. Okay. Event B intersect with A, and the event B intersect with the complementary of A are mutually exclusive. Is that right? What does it mean? A intersect B. A occurs and B occurs, right? If B occurs but A doesn't occur, A and AC are mutually exclusive, right? So that would make this term mutually exclusive with this term. Because when B occurs, there is two possibilities. One is B occur and A occur. The other one is B occur but A doesn't occur, right? Therefore, these two situations are mutually exclusive. Accidentally place a button. Is that clear of why these two are mutually exclusive? We can see like example. With this diagram, what is the probability that A occurs? Everything inside set A, right? What about this part, the shaded one? This would be PA intersect with complementary of B, right? Or B bar. What about this part? Right. So we can see that these two terms are actually mutually exclusive. Right? So from this concept, we can rearrange the function, the equation. This one, a general one. Conditional prop A occurs given that B occurs would be this. From this, we focus on this term PB. PB can be written as B intersect with A union with B intersect with AC. Just like these two terms, the union of these two terms would be equal to probability of A, right? That's why we have this new term here. Okay? And the top one, this term can be represented with this term conditional pop of B given that A occurs. Okay. Is that clear of how we get this one? Look at this term. If we switch between B and A, B given that A occurs, this term will still be the same, no change. This term will be changed to A, right? If we move this term to be on the left hand side, we would have the probability that A intersect with B equal to conditional pop of B given A times PA. That's what we get. Okay. So the next is the random variables. The discrete and the continuous ones. Probability mass function PMF and probability density function PDF. For a continuous one, the form would be PDF, discrete would be PMF, and the other term is CDF, cumulative density function. Okay, the relationship between CDF and PDF is shown in this formula. Okay, that cumulative density function would be just the integration of the PDF or the area under the curve of the PDF function, just like this. Small f(x), this is PDF, probability density function. Okay, so the area under the graph, this would be CDF, cumulative density function, right? So we can see that the cumulative density function is an increasing function because the summation on the area under the curve, okay, at the value x would be increasing, right? Always sum up, so the value would be increasing. So when x is approaching infinite, fx would be approaching 1. So later on we are going to see what's the relationship between these functions and reliability. Okay, in a discrete form, instead of integration, it would be summation instead. So the CDF would be the summation of the PDF, right? In a discrete form, then probability would be in the range of 0 and 1. This is always true for any form, for discrete or continuous. The summation of the probability that all events occur would be equal to 1. The mean of distribution can be calculated as a summation of xi pxi. The variance also can be calculated once we know the mean. Okay, so these are like